So thank you for coming. This talk is, as you can see, Cybercrime the Developer, how to start defending against the dark side. If this is not the talk that you expected, and there's nothing to do with stylists here, you have to go somewhere else. Yeah. I was quite impressed. I almost didn't come to this conference because I got to the main door and all this said stylists, and I thought, wrong place. But then I saw the JAX bit, so that's okay. Right. So, me, Steve Poole. I work for IBM, and I have for a long time, far too long. You can tell I've been doing Java on and off since before it was one, when it was baby. And I helped bring Java into IBM, and lots of Java, lots of open source, lots of stuff. But actually, this talk comes from about some other thing that I do and that I've been doing the last couple of years, is focusing more on development pipelines and DevOps and pieces like that. I wanted to go learn this stuff, so I thought, I'll go learn this stuff. And I learned a lot of things, and I want to share them with you. So I'm not a security person, I'm a developer. I'm not going to talk to you about application design. I'm going to talk to you about something much more important, okay? So this talk comes from the fact that when I started looking at the DevOps piece, people get saying to me, when you deploy your systems into the cloud, they need to be compliant. And I went, I don't know what that means. What does compliant mean? Why would I do that? And so I went out looking. And I came back and went, ooh, this is really interesting. And I'll tell you what, if this talk was happening at the tail end of this month, it would be a great Halloween talk. If you guys don't leave here a little bit worried and scared, then I've not done my job properly. Right? So I went out, went out and looked at all the what does compliance mean and what does it mean to my teams, my developers, my customers, and that's what I'm going to share with you. We do know, some of this comes from, I know that if you gave developers unfettered access to things and say, go deploy, here's some money, go spend it in AWS or SoftLayer or whatever, that the next thing you know is that those systems have been hacked. I did this talk at Java 1 earlier this year, and one of the guys who came and talked to me at the event afterwards said, you were right, we've just put a new system in, and he said, we found out 15 minutes after it was hosted, somebody was knocking at the door trying to hack in, right? And so a lot of this is about what happens when in the cloud, but it drives your general behavior, right? A lot of this has to be how you think and about how you need to change the way you think. So as I said, it's not about application design, not going to talk about that. That's a different set of talk. This is sort of lesson zero, ground zero, and we're going to go through that. So I'm going to talk to you about cybercrime, what the problem is. I'm going to talk about who's being targeted. I'm going to talk about who the bad guys are, and so we can talk about those. I'm going to talk about how they get into your systems, which is all really easy. And then we'll talk about what things we have to do to change. And so much of this is going to be behavior rather than something change this code, though there is some coding conversation here as well. So let's start with, some people go, how do people have a secure system? Right. And as I've discovered, many people don't even know what that is. They don't really understand what a secure system is. So the red lines aren't me. Is this your system? Do you have a vision that you've got a castle and a big strong firewall around it and it's fantastic? Whether it's on-prem or in the cloud, it's solid. And you might claim that to anybody who asks you, but the chances are your system's a bit more like this. Right? That's what you know you've got. It's not as secure as you want. You know that somebody could probably get in, but nobody's ever going to hack you, so, what the hell. Well, if you don't pay attention, this is going to be your application. It's going to be broken, and it's going to be gone, because the consequences of the security breaches now are big. Cybercrime is everywhere. It's really, really big. Organised cybercrime is the most profitable type of crime. Now, I don't normally turn up at these conferences and say, hey, I'm from IBM, let me sell you IBM stuff. I'm a developer, I talk about technical stuff. But when I went off and talked to the guys who do these things, I've got little bits of information. And okay, these are infographics, but the sentiment is clear, right? There's lots of people out there trying to get into your systems, and they're making lots of money. Organised cybercrime this year, 2016, as far as they can figure out, this year cybercrime is more profitable than the drugs trade, the illicit drugs trade. As you can see by the numbers, it's just peaked it. It's estimated to be worth $445 billion. Okay, the UNOCD said the drugs trade was worth 435. So, noise really, probably. But the point is, it's now that easy. It's that profitable, I mean, right? And guess which one has the least risk? Which one can you do and not get caught? Okay, which one is growing the fastest? Right? And which one do you think is hardest to prosecute? Not only because they're hard to catch, but when you've caught somebody, how hard is it to prove that somebody was engaged in cybercrime, right? And which one is predicted to reach $2,100 billion by 2019? Let me put this in context. The drug trade, that number is 1% of the world GNP, where it's going to be reaching 3 or 4 or 5% of GDP, and there's no sign of it stopping. Right? And they're after data, they're after your mobile devices, they want stuff, right? They want to steal your data in all sorts of ways because they can make money out of it. And they don't necessarily want to steal your data in ways that you would notice, but if they can steal your identity, then they make money. If they can, you've probably heard of ransomware and things like this, where they encrypt your data and charge you for it. It's very sophisticated. It's not really part of this talk, but it's worth looking into, because the reason not really part of this talk is because it's quite visible. There's a whole bunch of invisible stuff that goes on that we're going to talk about. But the point is, it's happening all the time, right? It's big. Your first lesson from this session is, this is real. This is coming to bite you. You have to start paying attention, right? And the key players are the people in this room. Okay. So what are they after? What is it that these bad guys are trying to steal from you? Well, as I said, it's starting to become invisible. So it's not just credit cards. Credit cards are worthwhile, but it's not the only thing they want, right? They want long-term identity theft. They want you. They want to know, they want your national insurance, your social security numbers. They want your life, right? Because you can't get your life back once it's been stolen. And I'm sure you may have read of a few people who've had that happen to them. Getting out of that position is really hard. But more than that, if they've got you, they've got inroads into your company. And if they've got inroads into your company, they can steal money from your company. And they can steal data from your company and make profit from that, okay? They want you, medical data. Medical data gets them into buying drugs in a legitimate way. There's so much information that we own that is profitable to other people, right? And if they can get insight into how you work, and as you'll see, they can use that against you to get more information. And it's just a vicious circle. So this isn't about hacking sites so that you know. This is about things happening so you don't get to see it until it's too late. In some cases, you'll never know that they will steal the data from you and use the data, because little bits of data that you own can be put together to create bigger pieces of information, right? So it's about everything about you. Everything about you is valuable, right? So let's start with your name, okay? So can I find your name? Well, I can find your name. Can I get your email address? Yeah, probably, because you probably share that on the web. Probably get your Twitter handle, that's good. Can I get your date of birth? Well, maybe you don't think you share it very often, but I bet you've gone to a few of these places where you want to watch some adult movie, or you want to go and download some software, or you want to go buy something, and it says, put your age in. Put your date of birth in. You'd be surprised how many people put their real date of birth in. If I have your date of birth and I have your email address and your name, I can go to somewhere like ancestry.com and I can look up when you were born, and I can find your mother's name, your mother's maiden name, so I can get in there, right? I can go to Facebook and I can find out what your favorite pet's called, because you probably put it on Facebook, right? I can go find out what you talk about your boss or any of your people, your colleagues, because you share that information in places that these guys come and read, right? The more they know about you, the more they can get in, and I'll talk about that in a second, right? So, and then the more they know about you, the more money they can make, because they can sell it, right? Right. So the other thing is, I said all attacks are more than technical. We've heard of social engineering, And probably you think of things like this. How many people have had some sort of spam like this, right? And if you can see it at the back, it's a bit small. But your ATM card of $10 million was returned, and if you don't give us the money, we'll keep it, right? It's the standard classic piece of spam. Everybody gets it, right? Okay. So you're not going to fall for that. Okay. How about this one? This one came to me. Federal Bureau of Investigation, and you go, and then it's, what does it say? It says, due to past corrupt governmental officials who almost held the fund to themselves for their own selfish reasons. I think that's great in a government email. So you're going to spot these, okay? Okay, you know those, you've seen them, okay? This is another one that came to me. I love this one, this is really good. Dear winner, I have won a brand new 2016 model BMW Hydrogen 7 series car. I don't know if that exists, but I'd like one. A check for $500,000 and an Apple laptop, which is obviously on par with everything else, right? Yeah. So you get these and you go, yeah, silly, okay? Because nobody falls for those, do they? Of course not. How about this one? How about maybe you're not a developer, but you're sitting there at your desk and you're busy and you get this email, and it's from your boss, and it says, I've just spoken to these guys, and if you pay them now, we can do some business, right? And don't distract me. Now, first off, you might go, well, why would I fall for that? But if you're in a situation where you're dealing with Italians and your boss is somebody who doesn't like to be disturbed and plays golf, you might go ahead and do it. And that's what happens. People do that because they've been social engineered, because people have gone to Facebook and found, I hate my boss, he's a real bully, right? Or I'm working on this thing with the Italians. And they put it together and you get emails like that, right? And it happens all the time. This is another real one. So this goes to people. So the takeaway is those silly scam things, which we'll talk again about what they're targeting at, you might not fall for them, and the majority of people don't fall for them. But what's happening now is that these targets are being refined. What we've got is criminals who are IT savvy, and they're industry savvy. And they're targeting people who are not IT savvy. So this is ones where these are like transport bills, and it gets sent to a company and it's all very urgent and it looks totally official because it's been created by people who know what they should look like. It's a forgery. It's people putting their time and effort to make it happen, and you fall for it. This particular instance, you get a downloader and you've got malware in, okay? Or how about same sort of thing, email instructions to somebody, downloads an Android app, and it's got an SMS hijacker. So every time you start sending text from your phone, it gets routed to somebody else. These exist, right? So this brings me on to an important thing that you have to start getting your head around, because we're not very good at this. Never install software without checking its provenance. And that's going to come time and time again. And you guys have got to start doing this. You've got to start thinking about where you're getting stuff and some of the possible bad things that can happen. So we're moving away from this sort of general phishing thing to more personalized attacks. You can see phishing, there's a thing called spear phishing, which is more deliberated, to personalized attacks, attacking you or people in your company, right? And organized, focused action by people who are serious about it, who have the skills and the tenacity to go off and do this, right? As I said, they'll go look at Facebook, they'll read you, right? This is serious. They are out looking for you. I can't stress that enough. They're out looking for you. They may not be looking out for you personally, but they're out looking for you as a group of people, right? So they're targeting people you'd expect, middle-level executives, people who are afraid of their bosses, people who are open to these sorts of, oh God, I've got to do it, I mustn't check with anybody, right? New joiners, here's the instructions. Oh, didn't know any better. That happens, right? Busy and harassed key individuals like the ones before. I'm too busy, something comes in, it looks reasonably legit, press the button, go off and do it, okay? And of course, the perennial, we actually find that there are people inside the company who will do things for money, right? disgruntled employees. I find you on Facebook or wherever, Twitter, I find you and you're not very happy and somebody reaches out. I only got to find one of you and then I've got somebody on the inside. And it's the same with all this. It's going out looking for people who are in this state, right? Right. The bad guys prey on the weak and ignorant. Developers. The bad guys prey on the weak. That's you. Developers are one of the weakest links in this environment. It's really scary to think about, but I'm going to take you through why that's the case. Now, we can forgive our customers and our non-IT guys that they might not understand the IT piece, but you guys do, right? So you know the inside story. You know how the systems work, right? You write the code. That's good. That's another weakness, right? You will have elevated privilege. The chances are, one way or the other, you've got some root access or some admin access that other people don't have. So if I can get at you, I get into that, and I can go somewhere else, okay? You're over-trusting. Now, this is the biggest thing. As a community, we are super trusting. We are very open to individuals. We're very open to sharing. We don't trust. We do trust. We trust all the time, right? We use other people's code without inspection, and I'll talk about some of that. There's just so much space. You know it. You will go to, you'll go to Stack Overflow, you'll go to GitHub, you'll Google for stuff. How do I do this? Oh, thanks, piece of code. And maybe that piece of code itself isn't bad, but your attitude to, I didn't even check it, I just found a solution, is a bad thing now. Because it's more than, that's just a slippery slope. I want you to think about how often you go off to the web and you go get stuff. You know, oh, I've got a problem, right, I need to install something. You know, I need to put something into my Maven config or my Gradle config or my Ruby gem, and I just go, it just says, put in this thing, you know, require X, and it turns up, and you don't think about it, right? But you've let code into your system and it's running, right? And you don't think about what that means. Okay, so I will assert right now that we are one of the weakest links in this environment because we know better, we should know better. Right. And what I want you to start thinking about, because it's a big problem, is not about the technology, not about how you design your application, but the first level down, how you think about creating things and how you think about getting stuff in. Where you go off and where do you get your software from? How do I trust people? How do I not trust people? What do I do? What checks do I put in place? Right? Right? Because you guys do these sorts of things. You ever tried this? How about Googling for how to trust any SSL certificate? You're a Java programmer. Yeah, it's very trusting. These are all nice Google queries. You know, how do I disable certificate validation in Java? We've all done it, right? We've all done this. You've all written code like this, right? Is client trusted? True, right? And you do it for the right, you do it for good reasons, right? Because it's easier than fixing the problem that's causing you to do this. And we do this all the time, right? But we do more than that. We do this. We turn off the checking on the tools that we use. This is so often. So if you're listening, these are all the options you can use, apt-get or wget or curl, to turn off the certificate checking. Those certificates are there to help you not to do silly things. You turn off because you go, well, that certificate on that server, it's untrusted because it's self-signed and stuff like that. So, but you don't do it for an individual server. You just turn it off for everything else because it's easy. That's why we do a lot of this stuff, because it's easier for us, right? So we've all done that, okay? And as I say, we do it all the time, right? The whole world does it. How bad can it be? I did a GitHub search for implements trust manager, and I found 72,000 hits. And you can see I just picked out a few of them. So how much code are you relying on that you've taken from the net where it's got the certificate checking turned off because they've invented the all-trusting cert HTTP requester, right? Do you even check this stuff? Right. Okay, I didn't. Right. Now I go, I don't even know how to check it, but now I'm worried, right? Because we do it all the time. This is NPM, so JavaScript space. It says NPM is the package manager for JavaScript. Find, share, and reuse packages of code from hundreds of thousands of developers and assemble them in powerful new ways. And that's brilliant. We love that. But caveat emptor, guys, because if you just go use that without thinking about how you know that that's good, or how you're going to restrict the use of that code in such a way that it's not going to leak out and steal everything from your company, you've got to start thinking that way. So whether it's that, or Maven repositories, or Docker, I'll talk about Docker, Linux repos, we're all very good at saying, I trust these guys because I trust these guys. It's not a random website. I know about Ware's websites, but I just go off that place, it must be good, right? And we'll talk about the NPM one in a minute, right? So you have to start paying attention, because we have to start dealing with this problem, and you need to start internalizing the challenges that are coming up. And it's a big challenge. But if we don't fix it, if we don't start thinking about doing things differently, then it's going to get very, very bad. So let's talk about who's coming in. The bad guys. Not these guys, because obviously if it was, we'd arrest them. No, these are some random pictures of people from the past who apparently were criminals. Yeah. So who are the bad guys, right? So the first thing you have to remember is they're you. So not you individually, but the group of people are developers. They operate like startup companies. They do scrums. They do iterative development. They're highly motivated, as you can imagine, right? And they always find ways in. They're all very keen people because they make loads of money at it, right? And they're very goal-focused, possibly for more reasons than the money, right? The interesting thing is average age of cybercrime is 35. What we've discovered, or what's discovered, is actually these guys are actually already into crime. So the good news is it's unlikely to be the IT professionals who've been in the industry for a long time, and it's more likely to be the people who are new. In fact, what they discovered was a lot of the people who are doing this are coming from a background of already being in crime, and they are learning IT. So all that help you're giving on Stack Overflow to people, how do I do this? Do you know who you're giving the help to, right? But this is what's happening. We've got these guys coming in, right? The really scary thing, and this is where I said about this being the most profitable and probably the safest form of crime, is that they don't get caught. Generally, it seems that the reason that these people get caught for their cybercrime activities is because they were already doing something else that they got caught for, right? So cybercrime as a crime is almost undetectable, and you just can't catch the guys. They end up catching them for other reasons. Oh, right, so, that was good. Let's do that one again, sorry. So let's talk about how they get in and some of those activities. So there's the basic ways. Social engineering, I thought they convince you to get in, right? And you, as I said at the beginning, you think you wouldn't fall for these things, but actually you'd be surprised. You would be surprised at what you would fall for. But that's the social engineering. And what can we do about that? Not very much. You just have to be more aware of the value of the stuff you've got and how you're going to defend against it. But you need to have your eyes open that you are valuable, and what you do and what you know in all walks of your life are valuable, because you're a developer and you have the keys to a lot of valuable systems. Cybercrime, IT, you're the gate, right? So social engineering, vulnerabilities, which we'll talk about in a sec, because though you might just ignore all that, that's really important too. And inside information, well, you can't do much about that, right? There are things you can do, but in general, again, it's like social engineering. You just have to be aware. So insider information, I'll give you a really simple thing. How many people have ever told somebody else an important password by writing it down or telling somebody across the corridor or across the partition, right? Yeah, I know you have, right? Everybody does it, right? It just happens, right? There's one where you leak important information, right? And the trouble is there are ears, or the note gets picked up by somebody else, okay? So they can get into your system through these ways. So let's talk about vulnerabilities, because this is interesting. I'm sure that, like me, when I first started, before I got onto this, what I used to do was, I've got to put some patches on. I have compliance, it says put patches on, or I have updates to come through Windows, and I have to keep doing it. And you just get into that, oh yeah, okay, right. But you don't pay attention, you just do it. right? So why is this important, right? So the bugs that you've put into your system, now I should say, when you're looking at vulnerabilities and when you start digging into the vulnerabilities, they're not big smoking guns. You won't know possibly that you've written a vulnerability. You've just written a piece of code that maybe doesn't do exactly what you expected and somebody else will use it a different way, right? We have a lot of people out looking for these because it's the combination of these inaccuracies in your software, unexpected behavior that gets linked together. We have researchers doing it and we have the bad guys doing it. We have, governments behind trying to find these vulnerabilities because they get into your system. I'm talking about cybercrime, but cyber espionage, cyber warfare, you talk about it, this is where it's going. But cybercrime right now is the thing that's top of the list because, to be honest, it's the easiest, right? Because if you're targeting governments and things, hopefully you think they've probably got slightly better security than Joe average. Right? So if you want to go see what there is, there's a great website, cve.mitre.org. It's worth going. These are some queries I did last year, so you could go do the thing. But basically, you can go to this website and say, what is there in any particular space? So what have I got? I've got Java ones, I've got serialization, JavaScript. You can pick them. Go have a look. It's worth having a read. I suggest you start having a look at this stuff. It's interesting, but it's worth digging into what's underneath of these and just seeing the scale. How many are coming out? What areas? So when you start thinking about technology and you start making technology choices, this is a good place to go and see what sort of bugs and problems there are. But it also gives you an idea of what a vulnerability is, because you probably don't get, because you've probably not been that bothered about what a vulnerability is. And this will, if you go have a look at this, you'll see they're not necessarily big things. I mean, it's like Heartbleed. Everybody heard of Heartbleed? We had this wonderful thing. Heartbleed was a slight bug which you could ask for some memory, and you're supposed to ask for a small amount of number, but if you ask for a large amount of memory, you get a brain dump, right? And you go, okay, it's not a big deal. But if you have a determined attacker and they keep calling this, eventually they have a fairly inconsistent view of what's in your memory. And if they've got the whole of your memory of your application, I say not totally consistently, but enough for them to start poking around and getting hold of data. And that's why that was so important, because it's just a simple door that anybody could use to get into your system. So it's these combinations that get you. Occasionally you get a big exploit, but that's more to do with its impact rather than the fact that it's a big smoking hole. It's that somebody's discovered if I do A, B, C, I can get in. Researchers find it, the criminals are out for it. And like zero-day exploits, that's it. Somebody found out, right, that you've just put an update on and somebody's just found there's a problem with it. And they're exploiting it like this, right? If you go look in the security field of IT, you will find there's a large number of people working in this space, but it's not feeding over to us. We're not really paying much attention to what's happening in that space. Right? Vulnerabilities. You have to work harder at vulnerabilities. I mean, what can I say? It's a chore, but you have to be saying, I understand why I'm doing it. Go look at the fixes that are coming through and start looking at what sort of problems they've got, because you can make informed decisions about whether it's a thing you want to apply or not if you start getting informed, right? You have to do this. Let me put it like this, if you don't patch things and you're running in the cloud, so in the cloud, you've got more public access. Right? You may not think it is, but there's more public access. So if you deploy something to the cloud and it's not fully secure, the moment you deploy it, within 15 minutes, at least within 45 minutes, somebody's trying to get into your system. Right? And if they know what OS you've got and they can start getting the first teasers of data, they can start targeting you with some of the obvious vulnerabilities that you should have patched. Okay. And it gets worse. That's the traditional stuff. And then we have devices that sit in your network. Right? So I'll talk about eavesdropping devices in a second. Ransomware, blackmail, yeah, we'll forget that. But devices are really horrible. You've got devices in your network, printers and things, that you just connect in. They have IP addresses, they have default passwords. Guess what happens? They get hacked. They have computers in them. They get hacked, they start doing something else than they were intended to, right? What else goes on? Extending malware into real products. That's really good. Helpful stuff. Docker images. How many of you have downloaded anything from Docker Hub? Yeah, okay. How many of you checked to see whether it was authentic? Right? How many did any checking? Right? How do you know that it's useful? Yeah, okay, it's useful. I go download something for Docker. Great, I get the effect A that I want, but I get some side effects, potentially, because somebody has been very helpful and given me some free software. Do I trust the person who did that? So there's dangerous paid stuff. This is the psychology. If you pay for it, you'll trust it more, right? And there's some classics like game trainers. So if you're like me, you play games a lot, then there are times you go, I can't win this game, I'm going to buy a trainer because that will help me cheat. And you go, yeah, I'll pay for a trainer, and it runs in your machine, it gets flagged as by the antivirus system. You go, yeah, I know, because it's terminate and stay resident and stuff like that. That's fine, it's run. I know what it's for. I've just let a big piece of software into my machine to do things and given it a load of permissions that I probably shouldn't have done. And then a couple others like, excuse me, at the source injections. People give you a pull request. If you're an open source, excuse me. So people give you a pull request. It's very helpful. How well do you check the code? Well, actually, how well do you trust the person who's doing it? Right. So you have to start thinking about, I need to start building a trust relationship into my thought processes. When I'm taking stuff from people, pull requests, it's lovely, and you might sit there and go, yeah, this is really great code, but how thorough are you, right? And how often are you going to do that? Like unknown helpful people, it's quite interesting. You can have people turn up and go, I'll do that for you. I'll do the nasty work for you, right? I'll do the merging. How many of you, a lot of you are using GitHub one way or the other, and you get pull requests and you get Git merges. And Git merges is this code and this code come together, and you get a new set of code. The new set of code can have no relationship whatsoever from the two child sets of code. Anything could be inserted, right? Do you check? Do you trust the person? Yeah, he's a nice guy, he just does it, right? It's that sort of thing, right? These are the opportunities that people are looking for. Right. Devices inside your network. Oh, well, this is really good. This is happening all the time. You have to go look and see how many places you've got a smart thing, and how many times that smart thing has a default password. It's really scary. Every single one of those devices that you've attached, whether it's bring your own, whether it's printer, smart TV, you name it, if it's plugged into your network, then it's at risk. Did you even know it was there? It's got default passwords. How many people use Raspberry Pis? Anybody use Raspberry Pis? Yeah, Raspberry Pis, you get one of those, comes with the default password because it's easy, right? People don't change it because then I have to remember what the new one is, and I'll just use the old one because everybody knows what it is. How about having those on your network, right? They're at risk. So you have to understand that your internal network is basically compromised. It probably isn't, but you have to deal with it from that point of view. And you have to start thinking about everything you do is public and accessible, right? So what I say, personal passwords. I hate passwords. We all hate passwords. We all hate having to remember horrible characters and combinations, and we've all hopefully all used password managers in one form or the other. The general advice is get away from passwords, try and use keys. And if you are going to use passwords, go for long passwords. There's a link here. It's worth reading what makes a good password. And it's not a complicated set of characters. The longer it is, the better. That's the simple answer. The longer it is, the more it takes to crack it, right? There's some simple advice. You know what it is. Just don't repeat passwords, don't share them. And if you give it to somebody, go change it, right? And you know this, right? But I don't know how many people actually follow this advice. And maybe when you start seeing what else is going on, you might change your mind. So, how about Wi-Fi? Wi-Fi gateways, they're cool, aren't they? Everybody uses those. How many people are wired up right now to JAX London Wi-Fi? Yeah, okay, right. They're everywhere, aren't they? How do you know that that SSID that you're connected to is real? Right? Well, you think that if it wasn't, you'd get something like this. Oh, when I go to Google and I get some invalid certificate. I'll show you in a way that that's not necessarily true. But the first thing I want you to think about is, what would you do if there was a little box like that stuck in the corner, or maybe under your chair, and inside that was something like this? Here's a USB power supply, battery, Pi 0 Wi-Fi dongle. Okay, could be anywhere. Hey, look, there's a white box in the back there. That could be broadcasting that Wi-Fi address, that SSID, and you could be connected to it. Right? Any Wi-Fi gateway that you connect to that's public, right, where the password is known. That's funny, because like this conference, like everyone else I go to, somewhere you can find, here's the SSID and here's the password, right? They could be compromised. How do you know that that's the SSID, that the device you're connected to is not something like this versus what you're expecting to do? And the answer is you can't, right? And this is where, amazingly, so many of us seem to spend our time. We go off to coffee shops, and we go connect to the Wi-Fi without a thought, right? And it doesn't have, it can be dry-fi. You probably may have heard of dry-fi Wi-Fi, drive-by Wi-Fi, where you have devices that people drive past your house and they put up a Wi-Fi that you think's reasonable. Yeah, you can go into Starbucks and people will spoof them there. You can just turn up because you have no way of checking, right? And people fall for it at the time. And it's easy to hack you, right? So let me talk a little bit more about some technical stuff. So I've talked about the people stuff. Let's look how some of this works. So HTTP, we know how this works. The yellow one is you. Then you have the blue browser, and you go to the gateway because you connected to, and it's all magic. You get to your website and you say, give me some data, and it comes back. That's easy, right? So how does that get hacked? Well, here's the first one. Okay, so bear with me. So what happens is the router doesn't pass the things through anymore. This is a man-in-the-middle attack. The first thing is it starts to have the conversation on your behalf, right? So you give him the data, or you put the request in. This thing opens the conversation to the website on your behalf, and it proxies the data back to you. So it's in the middle. It's seen your data going backwards and forwards. It's stolen your data, and you have no idea, right? HTTP, steal your data like that. Right? Now, you could think that you might go, if we make it HTTPS, it gets a bit more secure. And the answer is generally HTTPS is a really, really good thing. But you have to think about ways that can be spoofed as well. So here's a couple of them. So happy person, there's your browser. In your browser, you have some certificate authorities, and so when you get the certificate back from the website that you're going to talk to, there's some checking going on. So there's some handshaking. You get back a certificate from the target server, and it gets checked. So you trust your browser, and your browser has a bunch of certificates in it that it trusts, and it checks that server certificate against that list. That's why you get these things with self-signed ones failing, because your browser goes, I have no idea who signed that, so it's wrong, right? Hopefully, you've got a bunch of legitimate CAs in your browser, and everything's fantastic. Okay, so you have secure two-way encrypted. It's great. So let's hijack it. So the first thing, as I said, it's a two-way conversation. So you make a conversation to the router. It starts a conversation to the server on your behalf. Okay, so you think you're talking to the server, but you're talking to the immediate stage, and it's pretending and spoofing you. And the first thing it does is it doesn't send you back the certificate from the web server site that you thought. It's sending you back its version, and that's where you get the unexpected. Now if you remember those, you must have seen that when you're in that situation where you get told the certificate is bogus, you get a nice little very complicated web page up, and you go, is this valid? Right? Now chances are it's not, or that it's self-signed, but you can imagine a lot of people accepting it. Okay, and can be really hard to be certain on some of these cases whether or not it's you, or whether it's the gateway, and whether it's a bad gateway or just an intermediate gateway. Hotels are great for it. You sign up for hotels, and you get this situation where you know that it's that it's bogus, but you also know that it's reasonable, right? So anyway, what ends up happening is because you're talking to the router, and the router is talking to the gateway and onto the server on your behalf, you're sending your encrypted data to the router. Thank you very much, right? And all that is because you accepted the certificate, right? The thing about that one is at least you saw it. At least you knew that was happening, right? But bogus certificates. In your browser, you have a bunch of them. Some of them, so you're going to say, how will they get there? Well, they come from the browser provider. And the browser guys try really, really hard to make sure that they're all valid. But you have options like occasionally, they're not. Occasionally, they're bogus. They expire, but sometimes they don't get checked. So you have a bad one that they've been compromised, and you don't even know that it's happened because it doesn't get fed back to your browser. The other one is you may actually have a local one installed. Your company may have issued one, and now it's in your browser, okay? And that gets stolen. That's common as well. But in all those circumstances, there is nothing that you see. You have a conversation with a router that spoofs you, and all your data, you're having an HTTP conversation, but not with the target, but with the bit in the middle, right? And the point is, you don't even know it's there. As I said, it could be bogus, it could be one that your company's stolen. In fact, through social media, it may even entice you to install it, right? It may have sent you an email that said, from your boss saying, you need to install this now. Right? That's all I have to do, get it in there once. And then there's another type of man-in-the-middle attack. Let me do the picture rather than the words. This one might scare you a bit more, because this happens. This event happens, and you're going to say, "Ooh, don't know." So, if the first connection with a server you make is HTTP, right, then the data that's going to come back is going to be unencrypted, and there is a case where you have a router in the middle that's going to strip out the HTTPS-ness of all the links, or a specific link, because some of these guys know what the data flows are for your favorite websites, and they know how it all works, and they know what they're going to do. So let's suppose you go to Amazon and you make, I don't think you can do this, but if you pick your favorite website, you make an HTTP call to it, and it accepts it. It sends you back some data, but this thing strips out the HTTPS. So the HTML that comes back, no S. Your code does a post. Here's my user ID and password. Post. I've posted it in the clear. This guy's got it. Okay, what does he do? He's stolen your data. He just basically says, "Oh, website's gone. Recover error." You go, that's happened before. Refresh, resubmit. It happened. You've lost your data, and all because you're connected to a gateway that is random, right? You could be doing that right now, and it could happen to you right now. So the general thing is, you have to get really smart with this, right? If you're connected to a random Wi-Fi gateway, right, then you need to go get yourself a VPN, and not a VPN for just one set of traffic. You want a VPN, and those services are appearing where you're going from here to a gateway that you trust out to the internet. So all traffic goes through that, right? You have to know this. You have to start assuming, that the data you're accessing, about the validity of the data you're accessing, right? Unless it's a secure connection, you're going to get bitten, right? Because if you allow the bit in the middle to modify the data, what else is it going to modify, right? It's not just text, it's binaries and things like that. So the browser, that's one space. But as I said, with others, curl and wget and stuff like that, we build this into our tools. We turn off certificate checking. We allow people, it doesn't matter whether you're on a Wi-Fi connection or not, we let people download stuff. We download stuff, we don't check it, and because of that, it's easier for it to get spoofed, right? You've got to start doing something. The one lesson you have to learn from here is you have to go away and learn how the security processes work, how the protocols work, what they do, how you make sure they work, how you make sure they don't work, because you can't not pay lip service to this anymore. Right? It's always been seen, I mean, me too, we're going, it's just a tired thing. I've got security guys who do firewalls and stuff, and I'll do the rest of it. But we are targets, and we've got to learn to be better at this. And the first thing you've got to do is understand how some of these basic protocols work. Right? And as I said, we turn these tools off, right? For reasonable reasons. The server access is self-signed. Yeah, we all have that one, right? I want to access multiple servers because it's easy if I turn it off rather than deal with server by server, right? I thought I was using the tool correctly. One other thing that came out of some of these studies is that actually a lot of the tools that we use aren't very clear about the security settings, and it's very easy for you to turn the configuration off when you're meant to turn it on, right? So you just trust the tools, and you're letting these guys in, right? And then someone changed the script, and I don't know why. I started doing DevOps, and I started learning about infrastructure as code, and then I went, oh, okay, now I begin to see why having all these things under version control is so important, because this is the third thing about people doing it for money, right? Or just because they were silly. But you need to be able to start thinking about how I'm managing and audit tracking these things. How do I know that was a legitimate change? Because I have a record, right? We've got to start looking at how we use these tools. You've got to start looking at where I get them from, who gave them to me, what I'm using them for, how do they work, and not just, yeah, it works. I'm in a hurry. You've got to invest time and effort in learning these tools. You've got to start picking them and going, I'm going to use that one because that's the one I know, right? On average, a company tests less than half of the mobile apps they build and never test apps to ensure they're secure, right? That's really scary, right? And I mean, I was using an app recently to do with some payment stuff, and I'm going to the page that I type my password in is an HTTP page. And now the browser flagged it, so I'm going, I'm not touching this. But I understand now why I don't want to do that, right? So we take a lot of stuff down, code, tools, whatever, okay? We are too trusting. We trust people because they're good people. But occasionally, there are some not good people. And maybe the guy you trust is good, but maybe he's not very good at securing stuff, and he lets stuff in, right? There was this thing beginning of the year, March I think it was. I don't know if you saw it, but what this guy had a piece of code that was relied on by pretty much the whole world of JavaScript. And he, for various reasons, decided he was going to pull his code. So now it wasn't available, and everybody broke. Right? And it got fixed because the NPM hosting put their own solution back. Right? My point is that guy could have added malicious code. In fact, anybody putting stuff into any of these repositories could be adding malicious code. Right? So I'm not saying that you can do anything about it, but you have to start thinking about that that's true. So many people will go and will have policies within their companies about what's the license of that code that we're using. Okay? And you think about that, but you don't think about what's the provenance, who wrote the code, where did it come from, how would I trust that? And building that sort of that investigation, right? And I know it sounds like, oh, it's just effort, but it really isn't, right? This is getting far too big for us to be not dealing with this. And so I'm asking you to start thinking about where do I get stuff from it? How do I trust them? What's my trust protocol, right? So don't download or open or depend on random code. Simple things like examine the process left to ensure the code or binary certificates being hosted legitimate. What that means is if you went to, say, Apache, they would have descriptions of what they do to ensure the provenance of the code they're sharing with you is valid. So it's a security conversation. It's is the person who gave me this code entitled to give me this code, right? But they're the sorts of things you have to start checking for. What are people doing in the space of the code that you're consuming? What are the developers doing, right? Is it some company that you don't know anything about? How much are you actually paying attention to the code that you're bringing down, right? We suggest that most often you start thinking about having your own caches not only for performance reasons, because you can start to control these things. Start thinking about building caches where you put in there the stuff that you care about. Then you can start running some of the scanning tools. There are a bunch of tools out there now that you can use to scan for vulnerabilities, because sometimes people insert vulnerabilities. And of course, you can then change all those embedded passwords. It's take control of what comes down, put it somewhere in your company and tell people that's what we're going to come from. You want something, have a process of putting it onto there. Right? I really can't say this anymore. It's just scary. Right? The scale of the problem is getting bigger. It's invisible to us. It's coming. It's going to hit you. There's no doubt about that. Right? We are not very good. Really not very good at this. Right? And you look at what people are saying. Here's a really good quote. There are lots out there. So here's a guy, Frank Zahini, right? And he says, developers are over-focused on testing and scanning, right? Under-focused on poor software development practices, don't take a breath, that lead to vulnerable applications that hackers can avoid, right? What he means is, we're not paying attention. We are the guys who are going to fix this. So you need to go off and learn how to write secure applications for sure, but you have to start thinking about what you're building into your thought processes about what you're doing. If you make it easy for yourself as a developer, and you're a developer who's probably got elevated privileges, if you make it ezy for you, you're going to make it easier for the bad guys. And that's the bottom line. Everything you do to make it easier for you, backdoors, whatever, or if you start designing things to say, well, I'm not sure it should be A or B, so we'll let them do anything. Those sorts of thought processes, you've got to start questioning the consequences of doing it. Right? So I need to start thinking about these things, becoming more security conscious. Right? Thinking about how you're exposing your data, how you're exposing yourself to the bad guys. Right? You can't imagine that you come into work, you're in a room, everything's fine, and you go home and you have a personal life. Right? They're not that separate, right? Because you're the common factor. You're the one that people are going to be looking at, right? And it's not necessarily you specifically, but it might be your friend. It's just information that you share is going to let people in. And if you're not aware of that, and if you're not countering it, right, it's going to get bad, right? Oh, and by the way, if you have security architects in your organization, go buy them a coffee and bring them in, right? When we started doing the DevOps movement, we started bringing the ops guys in, right? And that's worked really well. Developers learned how operations work. So the security guys aren't in that mode. They're still out there, right? You go talk to security guys and they have a lot of the answers. They can tell you a lot of the information you need. They can help you design systems, but they're out there. Bring them in, buy them a coffee, make them part of your development process. What else can I tell you? All sorts of stuff, but you know these things, right? Don't let admin guys in from outside your firewall. Okay, you'd be surprised how many people let you access a system remotely using root, right? Whitelisting outgoing connections. You would not, maybe you haven't. One of the things be worthwhile doing is tracing. When you've got a time, take one of your applications that's running and see what outbound connections it makes. We're very good at building firewalls that prevent people coming in. We're not very good at tracking what goes out because, there's noise. But it's worth looking. It's worth tracking to see what goes out there, right? Docker, comment on Docker. If you download a Docker image and there's no Docker file associated with it on GitHub, Docker Hub, don't touch it because you have no idea what's in a Docker image. And if there's a Docker file there, then great. Get the Docker file, build the image yourself, right? Unless you really, really, really trust that Docker image, how do you know? You're now allowing an application that has root access into your system, right? Now, sorry, I'm going to blow this. But if that Docker image that you want to run says, will you mount a file system, you've now given an unknown set of code that's running root privilege access to your file system, right? And who do you know what it does, right? We concocted some really great examples of being able to steal SSH keys. I'll give you a Docker image that's got an Eclipse editor in it. You do some funky X stuff and there's Eclipse, wonderful. And you mount your home directory because that makes sense. And the next thing you know, I've got your SSH keys, right? Because you gave me access and you let something that has full power, right? Let's go off again, right? VMs are really good. Docker images are really good if you trust them or you build your own. Start thinking about, how do I compartmentalize my life? We use Docker, we use VMs for building microservices. Start thinking about how you can use those tools within your development environment, your development life, so that you are restricting. If you're going to use something, don't give it full access. Put it in a VM, wire it up, right? Build Docker images, Docker Compose. You can build some really great systems and keep everything nice and tightly locked down, right? Yeah, and don't add developer backdoors. What can I say? Backdoors, right? Why do you need a blanket God mode? Why do you need root access that gives you access to everything? Just because, right? Right? Would you have one key for every door in your house? Right? Would you share that key? Would you let the world know that, yeah, my key looks like this and it's the same as everybody else's key? Of course you wouldn't, right? But we do in the software industry, right? And we share them. Would you give your colleague power of attorney over you? No, but if you give them the root access, that's what you've basically done. Yeah, fill your boots, do whatever you want, right? Right? Would you remain ignorant of how your security system at home works? I trust it. Okay, does it go off when the door's open? Don't know. How does it work? Don't know, right? And it's what you've got to do now. This is the thing. If you don't start learning about how the security systems work, right, how the authentication processes work, starting to build, reducing your trust levels and being more informed, you're going to get bitten, right? And basically, one of two things is going to happen, right? Your company's going to lose a load of data and not know it, or maybe not fess up to it, but definitely not know it. Or your company's going to go bust, right? Because something fairly bad has happened. And I'll tell you what, companies that fess up to losing large amounts of data get a large amount of stick, and we know a few of those that do that, right? It can be unrecoverable, right? There's no magic wand here, right? I'm not trying to tell you how to design applications. I'm trying to get you to think about doing things differently and start to think about the size of the problem, right? I cannot impress upon you enough just how big this is. An ex-FBI director recently said that he didn't think that the cybercrime problem could be solved in our generation. But he said, we have to do everything we can to make sure that it's not worse for the next generation. Right? And to be honest, that starts here. You guys are the ones who go out there and say, I need to be more cognizant of the security side. I need to be thinking about, when I get something, wherever I get it from, can I trust it? When I share information, can I trust the person I'm sharing with it? And understand the context of your information outside work is still valuable, right? And that's it. Thank you very much.